Hello students, and welcome to today's video lesson. Today we are going to learn about slope and the rate of change of a linear line. We represent slope using a ratio. Slope is often referred to as the rise over the run. We also have a formula that we can use to find slope and represent slope. I'm going to write down this formula, and later down the worksheet I will show you how to use it. So we know slope is the y2 minus y1 over our x2 minus x1. We sometimes say, just for the record, this triangle symbol means the change of. So we often say slope is the change in y over the change in x. So now let's go through a couple of examples of finding slope. On this graph right here, we can see slope. We can find slope between this point and this point right here. What that will tell us is how much this linear or straight line is going up and at what rate of change that's happening. So from this point to this point, one thing I want to do is calculate how many times do I move up 3, 4, and go over to and how many times do I go over? So I went up 4 and over 2. So the change in the y direction was 4, and the change in the x direction is 2. So I can say this line has a slope of 4 over 2. Now this is a fraction. Remember, fractions are all division problems, so I can use that to simplify this. I know 4 divided by 2 is 2. I do like to write my slope as a fraction. I'm going to leave it as 2 over 1. So each time I go up 2 and I go over 1, I know that I'm going to land on my line, up 2 over 1. And that's an example of finding slope from a graph. So let's continue and find slope from this point to this point. Here I can see I go up 1 and I go over 3. 1, 2, 3. To go from this point to this point. So for this graph, I could say it has a slope of 1 in the y direction over 3 in the x direction. Now let's look at example 3 here. In this example, I want to go from this point at 0, 1 all the way to this point at 1, negative 2. Now here, when I change in my y direction, I'm going down. I go down 1, 2, 3 spots. To represent that going down, I'm going to say that's negative 3. That's what caused me to go down. Now, to go over to that point, I go over 1. So now when I'm making my slope, I need to keep that negative with my slope value. So the change in the y is that down 3 or negative 3. Change in the x is that 1. So my slope here is negative 3 over 1. Now, one way you might have to find slope, though, is from a table of values. So these 3 examples right here are all examples of linear tables. And we can find the slope from these tables. One thing we want to do is find the difference in our y value. So what do I do to go from 2 to 5 right there? I know to go from 2 to 5, that's a change of plus 3. And I can see that's a consistent change as I go continue to increase my x values by 1, that my y values increase by a consistent value of plus 3. So now to find a slope from a table, I want to have the change in y, that plus 3, or the difference there, over the change in x. So my slope here is going to be 3 over 1. So another example on number 5 is I want to find the difference in the x's. So what did I do to go from 2 to 4? I went plus 2. What did I do to go from 4 to 6? I went plus 2. What did I do from 6 to 8? Plus 2. One thing I'm doing here is checking that I have a consistent rate of change. If I ever see a rate of change that's not consistent, then this table might not be representing a linear value. We'll talk more about that. Now in the y direction, what did I do to go from 17 to 11? Well, I didn't add to that value 17 to go down. I took away. So I know to go from 17 to 11, I need to take away 6. So I minus 6. And to go from 11 to 5, I minus 6 again. And one last time, 5 to negative 1, I subtracted 6 again. So I can see I have a consistent change in my y and a consistent change in my x. And that's telling me that this is the table of a linear line. So now to write my slope, I would include that negative sign in my change in my y direction. So remember, slope's the change in y over the change in x. So I'm going to have negative 6 over positive 2. Now again, I can simplify this. Negative 6 divided by 2 is negative 3. And remember, I like to write my slope as a fraction, so I'm going to leave that as negative 3 over 1. Let's do one more example from a table. So here, to go from 8 to 7, I I subtract 1. 7 to 6, I minus 1. And 6 to 5, I minus 1. So I can see a consistent change in that y. Now in the x direction, to go from negative 5 to negative 2, I'm going to add 3. To go from negative 2 to 1, again I'm going to add 3. And one last time, from 1 to 4, I'm going to add 3. Again, I'm checking that these rate of changes are consistent to make sure I have a linear line. Now to write my slope, I want to do the change in the y direction over the change in the x. So my slope here is going to be negative 1 over 3. One thing I want to talk about is what makes these tables linear and how could we change number 4 so that it's no longer linear. Well, one thing that makes them linear is the constant rate of change in both the x and the y direction. So if we wanted to change number 4 to make it no longer linear, we could change a y value so it increases by something more than 3. That's one thing we can look for in our tables to make sure that we are working with a linear line. Now, one thing I want to show you is finding slope of between 2 points, not using a table and not using a graph. We want to use our formula from up above. So our formula for slope, again, I'm going to remind you, is that m equals y2 minus y1 all over x2 minus x1. So this is our slope formula. We can find the slope between these 2 points using this formula. Step 1, we're going to label our points. Remember, x comes before y's, and this is my first point here, this 5, 7. So I'm going to say this is my x1, and this is my y1. On the second point here, I'm going to say this is my x2, and this is my y2. Now, when I'm calculating my slope, I can do my y2 value, that 19, minus my y1 value of 7, all over my x2 value of 3, minus my x1 value of 5. Now on the top, 19 minus 7 is 12. And on the bottom, 3 minus 5 is negative 2. Now I do want to simplify this here. Remember, all fractions are division problems, so 12 divided by negative 2 leaves me with a fraction of negative 6 over 1. Now I can say this line has a slope of negative 6 over 1. One thing I will say is you can take your 2 points and put them in a table if you prefer that way. So here on this, on these points, I'm going to make a table of my x and my y. My x value here is at negative 1, and I got out an 8 on that point. Here I had an x value of 6, and I had a y value of negative 2. Now I can find the difference between these points. So what did I do to go from 8 to negative 2? I minused 10 from those values. And here to go from negative 1 to 6, I went plus 7. So now I can say my slope is my change in my y over my change in my x. So here my slope would be negative 10 over positive 7. And I could leave it there as a fraction. Two more points I want to talk about really quick Here, I'm going to use my slope formula again, my x1, my y1. This is my x2, my y2. One thing I want to show you is that you can do these many ways. I can use my formula. I can also use that table method from as well. This is something that you want to pick the option that works best for you. There's no right or wrong way to do these. So here, to find my slope, I'm going to use that y2, so that -5 minus my y1, which is -2. And then on the bottom, I had -7 minus, and then I plug in a value of -7. Now, one thing I did here is, since my formula has that minus, when I plug in a minus, I put it around parentheses. Now, I did that because what happens here with this minus? Well, when I have a minus, that turns it into a positive. So this becomes -5 plus 2. Now here, -5 plus 2 on the top, I'm left with a value of -3. Now on the bottom, -7 minus -7 turns into -7 plus 7. Now on the bottom there, -7 plus 7 turns into a 0. Now, when I have -3 divided by 0, this is something that I cannot actually divide. I cannot take a number and break it up into groups of 0. So this is the case where our slope is undefined. We are going to see this special case of slope when we have a vertical line. So when I have like a line like this that's straight up and down, we'll see a slope value like this where we're dividing by 0, and we say that slope is undefined. Now let's take a second and look at our other special case of slope. Here, in this one, one thing I'm realizing is that I have the same special case in this. So I'm going to take a second and actually change these points. I'm going to make this 8, 4, and I'm going to make this point 14, 4. This way we can talk about our other special case of slope. So on this problem, changing the values there, let's take a second and find the slope now. So finding the slope between these 2 points, I'm going to use the table method this time. I put in my x and my y value. My new x is 8, my new y is 4. Here I had an x of 14 and a y of 4. Now I want to find the difference. So what did I do from 4 to 4? I didn't do anything. I stayed right at that point. So I would say that's a change of +0. Here in the x direction, I had to go from 8 to 14. This I add 6. So now when I say I find my slope here, this is going to be my change in my y, the 0 over 6. Now this is a different value than what we got on this previous problem. Well, if I take 0 divided by 6, that's just 0. So this line has a slope of 0. And this is the case when we have a horizontal line. So if all horizontal lines will have a slope of 0. Hopefully you enjoyed today's video and you understand how to find slope using either your rise or your run, or finding it from a value of tables. I hope you have a good day, make good choices, be nice to each other, and be nice to your teachers.